Hello everyone, my name is Andi from University of Alberta. Today I'm gonna talk about a low-power intelligent IoT system for three-dimensional stress and strain monitoring applications. The Internet of Things is a key technology applied for remote monitoring. It is a system of interrelated devices and the ability to exchange data wirelessly with no human or human-to-computer interaction. Its architecture usually consists of three tiers. The first tier is the node. It is usually embedded with sensors and actuators that are responsible for collecting data. And then the second tier, the gateway, which links the node and the cloud. Final tier is the cloud that stores all the data. The power consumption is a challenge for IoT applications because many of them have very limited power. Frequently replacing battery is undesirable because some of them may be installed in a remote area. This research was to develop an extreme low-power IoT acquisition unit by integrating intelligent acquisition process to monitor three-dimensional stress and strain remotely. The figure shows a brace used for scoliosis treatment. Stress and strains are measured to determine the brace wear tightness and adjust based on those values. This is a block diagram of the acquisition unit. It is composed of 5 sections in total. The major component is a low power consumption microcontroller with built-in Bluetooth low energy for data transmission. The three-dimensional stress and strain sensors consist of 16 strain gauge type sensing elements with built-in temperature compensation capability. Each gauge is a single element resistor. By supplying a constant current, we can measure the voltage which representing the stress and strains. A total of 17 analog output values need to be measured, converted into digital, and sent to the microcontroller. Instead of using 17 current sources and multiple ADC, multiplexers was introduced to minimize the power consumption and the physical size. A rechargeable battery was used to supply power. Traditionally, people collect all the data and analyze them to find the problem. In this research, to optimize the data acquisition system in terms of power and memory size, dynamic sampling approach was applied. Normally, the sampling frequency is 5 Hz. When an abnormal change in stress and strain was detected, the sampling frequency was set to 20 Hz, which is higher for 5 seconds. Moreover, the system was put into the sleep mode while the data is not collecting. The top two figures show the printed circuit board of the sensing node. The left-hand side is the sensing board with a physical dimension of 20 by 20 millimeters, and the right-hand side is the sensing acquisition platform with the dimensions of 35 by 38 millimeters. The current consumption of the sensing acquisition platform was also tested. 4 mA, 5 microamp, and 11 mA were consumed in normal mode, sleep mode, and transmission mode respectively. The average power consumption was also calculated, assuming 10 triggered thresholds per day, which means 10 abnormal changes in stress and strain were detected per day. 0.67 mAh was consumed for each hour. In conclusion, an extreme low-power IoT acquisition unit was developed to monitor the three-dimensional stress and strain remotely. A lithium-ion rechargeable battery with a capacity of 1.3 watt-hour can support the acquisition unit over 21 days. Thank you for watching this.